Number 236. Number 236, we have y equals the square root of 6 plus secant pi x squared. I'm going to go ahead and put a parentheses around the pi x squared. Just make sure it's as clear as possible that that is being composed inside the secant function. Right? And we have another composition. We have 6 plus secant composed inside the radical function. So this is a chain with, you might say, two links in it, right? Or, well, I guess 3 links, 2 connections and 3 links. So to find the derivative dy dx, again, I'm going to use the tick mark notation. I want to find y prime. But it will help me to view this radical as a 1/2 power. So 6 plus secant pi x squared, all raised to the 1/2. Okay, so the most outer thing happening is the 1/2 power, right? The composition of the 6 plus secant pi x squared into the 1/2 power. So I need to do a power rule, right? And leave the inner function unchanged. So right now I'm viewing this whole argument as inner. Perspective will change in a minute. And the 1/2 power is the outer function. Again, most of this is pretty clear from the use of the parentheses and brackets, what is being composed. So I need to take a power rule. So the 1/2 power comes down, half. The inner function stays the same. So there's my present inner function. And I need to lower the power by 1 to negative 1/2. And that completes the power rule portion. But now I need to take the derivative of the inner function, the derivative of 6 plus secant pi x squared. I'm going to write in just notation, just for a moment. Okay? I still need to take the derivative of 6 plus secant pi x squared. So that's waiting to be done. Okay? So now that derivative will be 1/2, just rewriting the first part, so the derivative applied to this, the derivative will certainly just annihilate the 6 and cause it to be 0 because it's an additive constant, so I'm not going to write it. But now I'm also taking the derivative of secant pi x squared. So now we have a new perspective. Here's a new inner function, right? And the secant is the outer function. So I take the derivative of this expression here. Again, I'm really taking the derivative of the whole thing, but this goes to 0 immediately, and I'm really just focusing on this piece. The derivative of secant is secant tan. Okay? So I have secant tangent multiplied together. But the argument in here is going to be the inner function maintained from this expression, right? The inner function stays the same inside the derivative of the outer. So pi x squared should still be in here, in both of them. And I'll use parentheses just to show the composition there. So I have secant pi x squared tan pi x squared as the derivative of outer with inner left unchanged. But to complete the chain rule on this piece, I need to multiply further by the derivative of inner. The derivative of inner should just be 2 pi x, according to this power rule. So there is our answer, and it's all in terms of x. The only thing you would do now is try to clean it up a little bit. All you can really do is cancel this 2, that's all I see at the moment anyway, with that 1/2. Everything else should stay basically the same. So you would have pi x, right? Pi x moved to the front, it looks nicer. Secant pi x squared tan pi x squared, and then finally the secant pi pi x squared plus the 6. And there's our answer.